All right, now I want to talk about Ohm's law. Now, Ohm's law states that the current through an electrical device or component is proportional to the voltage across the device and inversely proportional to the resistance of the device. So if I were to draw this out in an equation for it, it would say that the current through a device is proportional, not equal to, the voltage across that device. It would also say that it is proportional to the inverse of the resistance. And this comes out to be a very simple equation that we are going to use that says that I equals, or the current through a device equals the voltage divided by the resistance. Now this is a very generic equation, and it is for our purposes going to be valid. Now this device, or this equation does not work for all devices, but it does, for the scope of this class, it is going to be sufficient for most of our calculations. This would probably be the most important equation that you have when it comes to electrical analysis or circuit analysis, because it does relate the three most important parts of every circuit: voltage, current, and resistance. Now, one thing I want to stress is that this through an electrical device, okay? So this is not dealing with the circuit as a whole. This deals with individual components within the circuit. And so when we use Ohm's law, it's easier to break it down into multiple equations with subscripts. All right, and I'm going to show you how to do that right now. Now, we like to have this in one row where we're not having a fraction. So the voltage, if I rearrange this, the voltage across a component is equal to the current through the component times the resistance of that component. And this makes it nice and simple. We don't have a fraction, and so it makes it very simple to do our math with. Not like it was hard to do math with before, but now we can actually look at it as one line, and I can actually type this in on a computer. It'd be very nice and easy. All right, so remember what I said about this being on individual electrical devices. Well, whenever it's on individual electrical devices, we are going to have a different equation for each device. And so the first equation I always like to start off is the total voltage. Now, the total voltage would be the voltage that we get from the battery or the voltage source. And if I put total voltage as the subscript, then the total current, it's going to equal the total current times the total resistance of the entire circuit. Okay, so if I were to have a circuit with two resistors in series, all right, and this is 5 ohms, and this is 10 ohms. Well, my total resistance, because they're in series, is going to be 15 ohms. So that equals 15 ohms. Okay, so the total resistance times the total current gives me my total voltage. And the total voltage would be the voltage of the battery, and the total current would be the current flowing through my circuit. Now, if I wanted to know the voltage across resistor 1, so let's say that this is R1, well, that's going to be the current through resistor 1 times the resistance of resistor 1. Likewise, if I want to know the voltage of resistor 2 or the voltage across resistor 2, well, this is going to be the current through resistor 2 times the resistance of resistor 2. So by taking Ohm's law and applying it to individual components, I now get the set of equations that I need to solve for all three of our major quantities in a circuit for each component.